Final exam review, page 2. Find all zeros of the function. So if it's x to the third, I'm going to use synthetic division to find one of my zeros. So basically this is trial and error here. I didn't know what to pick, but I know from using the factors of 10 divided by the factors of the coefficient here, I'm either going to use 1, -1, 2, -2, 5, -5, 10, or -10. Those are my only options. So I tried 1, and it worked. So remember, these numbers are coming from the coefficients here. And with synthetic division, you bring down the first value, then you multiply here, put it here, and add. Multiply, add, multiply, add, and if this is 0, then 1 is a 0, and x minus 1 would be a factor. So then these become the coefficients of x squared plus 3x minus 10 equals 0, and I can factor this by just undoing the FOIL. I need factors of 10. One's going to be positive, one's going to be negative, that have a difference of positive 3. And so it's x plus 5 times x minus 2. If you FOIL that out, you will get this. And so my 3 zeros of this function would be at 1, -5, and 2. In problem number 9, we want to divide and express the result in standard form. We've got a complex number in the fraction, in the numerator and the denominator. We're going to multiply the top and bottom by the complex conjugate. So if this is 7 minus I do 7 plus I, top and bottom. FOIL this out, and that's how I get this. And then I want to simplify by adding these two together, and I get this. In the denominator, when I FOIL it out, the outer terms and inner terms cancel. And I'm left with 49 minus I squared. But remember that I squared is -1. So 49 minus -1 becomes 49 plus 1, which is 50. And then what we want to do is put this into lowest terms. So it's this divided by this plus this divided by this. So it becomes 1/2 plus 1/2 I. Number 10, write in equivalent exponential form. So the base of the logarithm is the base of the power. The answer to the logarithm is the exponent. Number 11, evaluate log base 9 of 9. It's just 1 because 9 to the first power is 9. Evaluate log base 3 of 3 to the 8th. It's just 8. Number 13, write as a single logarithm. Remember that this number out in front can become the exponent, and then when you subtract, you divide. So it becomes this. To solve, we want to combine these two together using division because of the subtraction. And then you'll get log of this equals log of this. So if the logs are equal, then the two items are equal. Then you want to clear the fraction by multiplying both sides of the equation by 2. That will clear the fraction here. Distribute this, and you get x plus 9 equals 8x plus 2. Subtract the 2 from the 9, subtract the x from the 8x, and x is 1. To solve this equation here, what I did is I took the natural log of both sides of the equation. And then when I do that, I can bring the exponent down in front. So I get the exponent times the natural log of 4 equals the natural log of 187. I distributed the natural log of 4 to each of these terms, and I calculated out what the natural log of 4 is. It's 1.3863 times x minus, and then the natural log of 4 times 3 is this. The natural log of 187 is this. Then I added the 4.1589 to the 5.231. Then I divide by the coefficient. And I get that x is approximately 6.77. In problem number 16, I took the natural log of both sides of the equation again. The exponents are going to come down in front, so I have x plus 3 times the natural log of 3 equals x minus 4 times the natural log of 7. Use the distributive property, so the natural log of 3 times x is this. The natural log of 3 times 3 is this. The natural log of 7 times x is this. The natural log of 7 times 4 is this. Then divide this by this. And that's how I get 13.076. Number 17, find a positive angle less than 360 degrees, or 2 pi, that is coterminal with 445 degrees. Just subtract 360, and you get 85 degrees. Number 18, convert pi over 15 radians into degrees. Just multiply by 180 degrees over pi, and you get 12 degrees. Find the exact value of the secant of 17 pi over 6. I like to work in degrees, so I changed it to degrees. And it's 510 degrees after I cancel the pi and I multiply and divide. Then I found a coterminal angle by subtracting by 360 degrees. It's 150 degrees. So I did a 150 degree turn, and that gives me a reference angle of 30 degrees. So what I'm really looking at is 30 degrees. Using my 30, 60, 90 special triangle, the shortest side is 1, the hypotenuse is 2, the other side is radical 3. The secant is the reciprocal of the cosine. So if my reference angle is 30 degrees, the cosine would be ca, adjacent over hypotenuse, so the secant is the reciprocal of that, hypotenuse over adjacent. So it's 2 over radical 3, but notice what quadrant we're in. We're in quadrant 2. Cosine is negative in quadrant 2 because the x coordinates are negative in quadrant 2. So secant will also be negative in quadrant 2. And then the last step is to rationalize the denominator. So you multiply by the square root of 3 over the square root of 3. And that's how I get negative 2 radical 3 over 3.